Aileen Rizzo and Elin Anderson from the Ames Center will invite everyone to join them for an exploration of paper engineering magic. You'll want to have envelopes, pen or pencil, scissors, and a ruler or straight edge on hand for this hands-on fun.
All right, so welcome to our play break session, and it's called Paper Engineering Magic. My name is Aileen Rizzo, and I'm the Associate Director at the Ames Center, and I'm here with my colleague Elin Anderson, and we're excited to present this session to you. So at the Ames Center, we just wanted to tell you a little bit about ourselves because our values are really important about the work we do, which we find very meaningful. We believe that inclusivity and diversity are very important, even in STEM education. And I think that that's indicative of the underrepresentation that we still have through genders or other nationalities or cultures. But we also believed in human-centered. We believe that we learn through play, and that play is a great avenue for learning. So we hope that this play break will just exemplify that. We also believe in empowerment, and in these spaces where we learn, we produce an identity that we do belong in STEM, in STEAM places, and we hope that you feel that way too. So we're going to have a great time today. We're looking forward to doing this activity with you, and I just want to go over a little bit of what materials you'll need, because we do have a little bit of time still for you to grab those materials. So today you're going to need an envelope. And you can use one that you already have. So if you have an envelope that just came in the mail, you can use that. Just carefully open it on the top and not on the side, and we can reuse envelopes in this activity. You probably will need 2 or 3 because we want to definitely encourage you to still explore and think about other ways that you might do this activity. You'll need a pen or pencil, even a marker, a thin marker will work, something to make some marks. A ruler or straight edge, because we'll be drawing some straight lines, and scissors. Those are all the materials you need for this activity today. So if you didn't have them prepared, think about where you can find those really quickly. And I'm going to hand it over to Elin. She's going to give us a little bit of background about some of this exploration we're doing from 2-dimensional to 3-dimensional, and how paper is a rich material to think about that.
Yeah, so thanks, Aileen. And while everybody is gathering their material, again, we are excited that you are joining us for this play break. And you are going to be experiencing turning something from 2D into 3D. And we have some examples on the slide. We have some pictures of pop-up books, which you may have experienced yourself or shared with your classroom with your students. There's one with a really beautiful castle popping out, and then another one that looks like it may involve some Star Wars characters. And so you may have wondered, how do they make these books? What type of engineering does that involve? Because it does involve engineering. And when you have the book closed, it's flat, but then you open it and this 3D structure pops up. How do they do that? Well, the same type of engineering happens or you use when we are making packaging. So like, for example, this box that you see on the screen, the picture of the box. So many type of packaging that you encounter is produced so it's flat, but then it can be manipulated or folded to make a 3D structure that provides something that you can contain or put things in. Another example is food packaging. So of course we've all experienced some type of fast food that comes in a container, but have you ever, like after you eat all those delicious French fries, play with the container that it comes in and are able to make it so it's flat? So again, it's going from 3D to something that's 2D flat. I myself have been enjoying a lot of ice cream cones, so And I've been thinking about the packaging. So again, flat, but with a few simple folds, it becomes a box for ice cream cones, for cereal, for lots of different things. So today you're going to engage in an activity that involves some engineering, so thinking about transforming something that's 2D to 3D, so three-dimensional.
All right, so we're going to get started into our activity. This is supposed to be hands-on activity, so we hope that you're making with us. I'm going to switch over to my dot cam here and take you through exactly what you're doing step by step. So before we get right into the activity, you see my envelope is already set here. I wanted to show a few examples of just these kinds of folds that can be inside paper, because paper is a really rich material. So here's, a piece of paper, a piece of square paper, started off very flat, very two-dimensional. And just by putting these folds in, I really get this really rich way that the paper flexes, the paper is movable, but it also gives the paper a third dimension. It comes out from that 2-dimension into this 3-dimensional space. And 3-dimensional space is what we live in. We live and breathe in that space. Other ways we can change something that's 2-dimensional to 3-dimensional is weaving. Weaving's been around a long time, but paper and the way we cut that paper and weave it together can produce not only this beautiful design, but you see the spherical way that flat 2-dimensional paper has now become a 3-dimensional object. So today, our example is going to take this very flat envelope and create a 2-dimensional shape with it, right? So like I said before, you can use an envelope that you got in the mail and recycle it, as long as you're careful to open it right at the top, because you'll see that top piece is the piece we're going to discard. So I'm going to use this envelope that I already have prepped here. And I'm going to make sure that flap, that where I would put something inside, is at the top, okay? I'm going to take my straight edge. You can use any straight edge, it doesn't have to be a ruler. And I'm going to draw a line from this top corner to the bottom opposite corner. That's the diagonal of this rectangle shape that I have here. I'm going to make that mark because I want to find out where the two diagonals intersect. So I'm going to take this here and draw a line, trying to be pretty precise that I go from corner to corner. I'm going to do the same to the top right and the bottom left here. Drawing a line here. So anything, any straight edge will do, and any way to mark it. So if I hold my flap down, you can see that I have drawn in both diagonals of this rectangle shape. Okay, so now what I want to do is I can put those two materials to the side, these two tools, because I won't use them again. And what I want to do is I want to first look at what I have here. I have separated this rectangle into 4 regions. And what we're going to do is we're going to cut out the top region, okay? And you'll see that looks like a triangle. So I'm going to cut out this top triangle and make sure that I try to do it as precise as possible, following those lines to the intersection point. I usually do it this way so I can get around that corner pretty precisely, and then start here at the top and then cut here all the way to that intersection point and then stop. All right, so this part that I've cut out, I'm going to discard. I won't need that piece. And you see that I have left, oops, this little piece here. You see what I have left is these 3 bottom regions here. These 2 triangles that are congruent to each other, they look exactly the same. And then just 1 left from the bottom piece. It was the same as the top, but I didn't need that top piece. All right. So what I'm going to do now is I'm going to put in some folds into where I've drawn these lines. These lines are going to be kind of my markers that are going to help me make those folds. I want to put a fold line here and a fold line here. And so what helps me a lot is to fold it back and just use that line as a guide and then fold right along that piece. If you're using a pen or a pencil instead of a marker, you have an advantage with me, because that leaves you just a little bit of a scoring that helps that folding piece be just a little easier. So we're going to go ahead and fold those down. I want to do a back and forth fold, which is called reversing that fold, to make sure it's nice and flexible. So you see I folded it down this way so I could use that line as a guide. And then I just reversed it towards myself and then refolded it down. Okay, do the exact same thing that we did on this side to this side. Okay, so again, I folded backwards so that I can use the guide, trying to fold it as precise as possible. With younger children, we want to make sure that we are alongside them, helping, especially with the corners that are a little thicker. But this is a great activity for young ones, a really simple way to make a three-dimensional object here. Folding it back, reverse, making sure it's nice and flexible. All right, so now I have these two pieces that have the fold lines inside of them. I just need to put one more in, and that one is going to go straight down the middle. So I'm going to just simply fold it in half, matching those pieces, putting that fold line in there, and then once again doing the reverse, just to get that fold nice and flexible. All right, so let's just go over exactly what we did. We have an envelope and we put in the diagonal lines using our straight edge and our marker. Then we cut out the top section and discarded that piece. Then we put in the fold lines here of our two sections. Then we also put in one straight down the middle. All right, so now we're ready to transform this envelope. What will it turn into? Let's see. So we're going to open it up here, like we were going to stuff it, and we're going to open it up here, and you'll see that it wants to go up to the fold lines on both sides, which is perfect because that's what I wanted to do. And then what we're going to do is I'm going to tuck this side into this side. So very carefully, going right inside there, and we have a three-dimensional shape. Let's see how many faces it has. Faces are these flat sides. 1, 2, 3, and where it's sitting, 4. It has 4 faces. And for a three-dimensional or solid that has 4 faces is called the tetrahedron. Also a very familiar word that you might recognize as shape is a pyramid, right? But this pyramid is a little bit like what we call skewed. It's a little bit slanted to one side. It doesn't, that point isn't right in the center, but it does produce this very interesting shape. And you can take it apart, look at the envelope again, flat, 2-dimensional, 3-dimensional, just stick that inside. What's interesting is that we can do that with various envelopes. So what if I had an envelope that was like a gift card envelope, right? Have a nice blue envelope here. Do the exact same thing, stick one inside the other, do the same cutting, and now I have another tetrahedron, right? Bigger. This one looks a little bit more straight on this side, like this is very perpendicular here. And what was fun is I was very curious, and I thought, what about a huge manila envelope? Would that work? I did the same thing. I cut out the top using the diagonals, and this one actually makes a tetrahedron. It's just a little bit more work, I think, to think about how it's going to, let's see, it's kind of fighting me here, fit inside of itself, but that one makes a really interesting shape here. But still a tetrahedron, it still has 4 faces. And so I leave you with this curiosity. What kind of different tetrahedrons will you get when you try the different envelopes that you have, because all envelopes are different. And it's just really remarkable to see the different ways that you get a two-dimensional piece of paper that seems really flat and sometimes boring, but just change it into something so different and so intriguing, and even a great way to maybe give a gift for someone, or make a gift box, or make a shaker and put some beans or pasta in there and shake it around. I mean, there's so many different ways to explore the curiosity behind two-dimensional shapes coming into three-dimensional, and the vocabulary. Vocabulary is so important, isn't it, Elin? So you were going to a little bit of this vocabulary that you probably heard me use when I was doing the demonstration.
I did. That was so cool. Yeah, I was listening to all the rich vocabulary that you were going over as you were doing this great activity. We had a lot of vocabulary that deals with spatial awareness, top, bottom, right, left, and then all the vocabulary words that connected with geometry. I heard diagonal, intersect, corner, region, triangle, point, congruent, lines, fold, half, straight, faces, solid, tetrahedron, skewed, pyramid. Oh my goodness, so many great vocabulary words that surfaced during this really fun activity. And you can see in this next slide, I got really crazy after the holiday break and turned all the envelopes I received from Christmas cards into, or some of them into these tetrahedrons, which are really fun. Sometimes it's fun to color different designs before you fold them, and then fold them in and see what happens. So that's really cool to do. And again, like Aileen, you were sharing, it's really fun to explore and try out different sized envelopes and see what happens. If it makes a bigger one or a smaller one, what size will the triangles that make up the faces of the tetrahedron, what size they will be depending on the size of envelopes that you use. So really, really interesting things that you could do with this activity. And on this slide, we also have a picture of a one-page guide that we have that goes along with this activity that is on our website. It has some really great questions that you could ask while you're engaging in this activity, the materials that you will need, and some helpful links on that as well. And so we have been exploring this idea of transforming something that's two-dimensional to something that's three-dimensional. And as you can see at the beginning, I shared some pictures of some pop-up books, and we talked a little bit about some packaging that you probably encountered that starts out as something that's two-dimensional, and then when it's produced, and then it's three-dimensional. But there are other things as well that go from two-dimensional to three-dimensional. And so we have this pull-up polyhedra, which is another activity we have on our website. We have a one-page activity guide for this as well, where you can actually form the net of a cube and then make this pull-up polyhedra. And Aileen has one that she can show us quickly.
So since it's really easy to go back to my dot cam, I'll go ahead and go back there. Yes, so we have one here, and this is a great activity, and the one pager will guide you through that, which also has an instructional video to help you. But what it is it a piece of paper that we fold so that we get this nice squares and make it into a grid. So that grid we then cut away some of those squares so that we can get this called a net. In geometry, these nets are like a map of what an object looks like before it becomes a three-dimensional piece. And what we have done is we've used this yarn to go through different vertices or corners of our shape here. And now when I pull it, and I try to pull them at the same time, those folds then give way and we can see our shape that we have. Now this is a different shape than the one that we just did. It's a very familiar one. We call it a cube, and it has 1, 2, 3, 4, 5, and the one at the bottom, 6 faces. And so this is a great activity for young ones, maybe at a center, to explore two-dimensional, three-dimensional. It also is great for introducing engineering, because the way that this shape can fold up is very intriguing, and how it's designed to pull at certain places and to just, come up at those places so that it becomes that three-dimensional shape. We also explored ways we can make these into little houses. One of my other colleagues, we cut windows and doors and did so many different things to just explore this shape, because children love stories, they love designing, and we know they're always, building little houses for their characters or their little dolls. I mean, so there's so many other ways to be creative. The art piece of STEAM is definitely important for young children. So we really want to see things through their eyes, the way that they playfully come to these activities, and side by side, be mentors and facilitators of those vocabulary words that are so important, like Elin mentioned. Because when children can have the experience to hang those words on, those words don't become like, oh, that's just a big word, they don't understand it. They understand it in the place of the experience. And then I've heard little kids, use words like rhombus and trapezoid, because they were playing a game and using those shapes in the game, and that made it important and that made it real for them. So we definitely want to encourage you to visit our website. There's a lot more resources there of these types of activities that use common everyday materials that aren't too hard to find, and you can engage young children around them. So that's definitely a place that you can explore further.
Yeah, we really have had fun during this time, and again, it's just so much fun to explore and think about how something goes from two-dimensional to three-dimensional. And I bet now that you have joined and played with us, that you will no longer look at an envelope the same way again, and we'll find different ways to engage and explore. We encourage you to join us this fall when we start up our next series of hands-online webinar. We'll be starting those up again in August. And if you want more information on those, you can go to our website at aimcenter.org/online learning. Those have been really fun. We've explored, we've done some more paper engineering. This past year, we've explored bubbles, designing boats, weaving, all types of fun things. So really hope you can join us this year.
We have our last slide just to stay connected with you. So we are putting that up there. If there's any questions you have around our resources, we also welcome you sharing your pictures, and make sure you use a proper hashtag or @ symbol so you can let us know and the Early Math Symposium know that you're involved, that you've done your hands-online activity with us, or maybe you're ready to use it in the classroom and want to show us some of the things that you're doing either virtually with students or in person. We love to see that and look at that from you. I think that's great as we come around as a community after the pandemic. There are ways that we can still reach out, and the online webinars that we've done at the Ames Center was a response to that, but we've gotten such great positivity. We hope that this activity inspires you to sign up for some fall sessions with us, and definitely come learn and play with us. We're always open to that space for you and welcome you to that. So thank you for joining us for this play break, and we hope that we'll see you again in the future.